All right, thanks for coming. So I'm Arif, I'm from ThoughtWorks actually, and I'm working with AutoScout now for about a year. I don't know if you want to say something.
Yeah, I'm Johannes Müller. I'm also with AutoScout and I'm the infrastructure architect. I'm working there since 2012. And I'm also very glad that you all found the way to this meetup.
All right, so before we go into the actual topic of UI composition, I'd like to give you some background about the motivation and the context in which we developed our solution to UI composition. And that context is a project, and we call that project Tatsu, which is what you see. So Tatsu actually means dragon. That's what you see here. It's the dragon. And we call it a dragon because actually this project is nothing less than a complete rewrite of the AutoScout 24 platform, which is live in 18 countries across Europe, and therefore we compare the project with a dangerous but powerful dragon. And in this project, which started a bit more than a year ago, we're basically doing 5 things at the same time. We are breaking down the rather monolithic old system down into a set of independent microservices. And we are also moving from a self-hosted system with our own data centers to a completely cloud-hosted system using Amazon Web Services. And at the same time, we're also moving from a Microsoft.NET stack to a Linux and JVM-based tech stack. And because that is actually not enough, we're also moving or changing the organizational structure from a structure where, an organization where we had several product teams that rely on a few operation teams to an organizational structure that more reflects the microservice approach with a more homogeneous organization of actually autonomous teams that are cross-functional and that actually have enough ops knowledge in there to be able to run, maintain, and create their own services. So that's what you see here with those gradients. And finally, as we are rebuilding everything, we also want to make sure that we come out of the whole process with a really shiny new AutoScout 24. And that's why we just cut out the most important parts and rebuild them in a shiny new way. So now this whole project is obviously a huge effort. So why are we actually doing this? So one of the reasons is actually to attract talent, which has been a bit harder with the old .NET stack. However, the main reason is actually to reduce time to market so that we can respond more quickly to user needs. And for this is actually important that new features can be released very quickly. Also just for doing A/B tests to get quick user feedback and so on. So the idea here is to be able to think more in terms of minutes for a new feature to be released than thinking in days, how it has been before sometimes. Now, for this to be possible, teams must be enabled to innovate independently. And we believe that a key to achieve this are autonomous teams that are able to independently create and improve and run their services. So you see this here, we have several teams. Those teams are cross-functional, so there are ops people and devs in there, and a team can have multiple services or just one service, and then those services are loosely coupled with each other. And for this to work, and for those teams to be autonomous, we believe that it's crucial to avoid any form of tight coupling as much as possible. Because if a team wants to improve just their own service in some way, but must wait for another team to release something in order to do so, then there is no real autonomy. So, in fact, we value autonomy or team autonomy so much that we also accept certain trade-offs. So, for instance, we often rather copy some code around than to create tight coupling by introducing a shared library or some shared infrastructure or so. Now, at the same time, we do not want to compromise page performance in any way. So, for instance, we want to achieve a page speed insight score of 95 or more. In case you're not aware what page speed insights is, this is a tool by Google that analyzes the structure of a page in terms of how fast it can be rendered. And that's in particular important for mobile browsing. And the score actually goes up to 100, so yeah, we're really aiming for excellent page speed here. We also strive for low latency, and therefore we need to benefit from caching at multiple levels. Now, in the context of microservices, it is actually a bit tricky to both achieve high page speed and high team autonomy. And in order to explain this, I'm now going to present to you two different ways how to generally approach this problem, and then afterwards Johannes will actually go a bit more into detail how we actually then try to solve that problem. Alright, so the first approach here is called the API gateway pattern, and that looks like that. So in this example here you see several microservices at the back end, such as the homepage service or the header and footer service. So the monolith here in this example is already broken down into several independent services at the back end. However, in the front end, there is still one web application that takes care of the whole web UI and that talks to the different back-end APIs. So, for instance, this red UI component here could talk to the homepage service, or that orange UI component here could talk to the header and footer service. Now, in order to avoid that the web application needs to start several separate requests to several backend services just to perform a single action, it is generally a good idea to introduce such a gateway layer here that aggregates those requests to backend services. Because this way the number of requests is considerably reduced, and yeah, especially for mobile devices, it's really important to decrease the loading times. The API gateway pattern is also particularly useful to deal with native mobile apps, as we see here. However, we won't focus on those native mobile apps today, so they're kind of a bit out of scope today. Now, of course, in this scenario, it's also fairly easy to optimize the speed and the performance of the page, of the web application, because yeah, all those UI components are within one application and can be optimized together. However, there are some drawbacks of applying this pattern, and from those drawbacks, actually, this one here was the most severe for us. You basically, with this pattern, still have a UI monolith, and you also have an API monolith. And that basically makes really independent feature releases impossible, at least as long as they contain UI changes. Instead, actually, in the worst case, 3 teams are involved when releasing a feature. So, for instance, yeah, something has to be changed on the homepage, and then the home backend team has to do something, and something has to be done by the team that manages the web application, and maybe even the team that takes care of the API gateway has to change something, and they have to be coordinated. So, yeah, because we actually went for microservices in the first place for team autonomy, this basically rendered the API gateway pattern no option for us. There are also other drawbacks, such as the danger of adding more and more logic to the API layer, or that there's kind of duplicated controller logic there. But yeah, for us, really this was the reason why we did not go for that. Instead, we went for another pattern, and you might have guessed it, this is the UI composition pattern. And this looks like this. So now with the UI composition pattern, each service delivers its own UI component. So for instance, the home service delivers this red UI component here, and the header and footer service delivers this orange UI component. And then later those UI components have to be composed to one single page. Now this way, actually each team can change their backend and their UI independently. And we also often here speak of vertical slices, because there is no layered architecture anymore, but each service can actually contain a backend, a UI, and everything in between. Well, however, there are actually quite a few challenges that come with that approach. So, first of all, of course, the HTML that is delivered by the different services has to be combined into a single page. Also, those services have to deliver their own styles and JavaScript to be really autonomous, or to be really decoupled. Furthermore, actually this HTML and those assets have to be consistent with each other, so in terms of having the right versions. Also, the page structure must not break page performance, and that is actually particularly tricky with that approach, because basically any service that provides a fragment or a UI component for that page could introduce some render blocking content, and by this would actually reduce the page performance of the whole page. And the same is actually true for the latency, because yeah, the latency of the whole page is determined by the slowest service that is involved here. And finally, independent testing of UI components and integration testing must be possible as well for this approach to work. Alright, so now Johannes is actually going to tell you how we actually approach that.
So, welcome everybody. As Arif said, there are quite some challenges that we had to solve because we chose this approach. And we started off with the simplest solution that we could think of, and we have heard of this solution, and that's what we initially tried to get along. So, who of you knows Varnish? All right. Who of you knows ESI? Well, okay. So for the rest, Varnish is an HTTP proxy cache. So it takes a request, gives it to a backend, and caches the response if it's cacheable. And ESI is edge-side include. It's basically a tag where you say, at this position, please also include something else from somewhere else. And why are we telling you our first attempt? Because it helps us to understand the problems that we faced with and our learnings that we got from this approach, and which helped us building our current solution. So the test setup looked a bit like this. Pretty easy. We started off on AWS. Everything is running on AWS on new infrastructure. So basically we have a browser, we have a load balancer from AWS, we have Varnish, and then we have some services like the home, header and footer service. Also Arif used those in the example. So that's kind of a good example, I guess. And yeah, so Varnish is taking the request and is going to the home. And the home tells Varnish, hey, I need header and footer, please include it here, and you see an ESI tag. So in the code, it looks like this. So you have basically your normal HTML page. This is the home page, let's say. And you have your styles. They are already minified and combined, so they are properly generated styles. On the bottom you have your JavaScript. Normally we would use defer async here, a good option. And in the middle we say, okay, here please include the German header fragment. And yeah, let's see what happens. So the yellow part is the resolved ESI include. So you get the content of the header fragment, and it also has its style sheets, and it has its JavaScript files and some content in here. So like we've said, every fragment or every piece should deliver its own styles and scripts. And the problem with this approach is clearly that CSS and JavaScript is loaded in the middle of the page. And a page speed test would probably show you a bad result. So we were a bit puzzled and said, okay, how can we resolve this? Another problem was that you need full qualified references to some styles, because it's not showing up under the domain of the request that it initially got. It's just the reference, so you need to have a separate domain for your assets. So we were not really happy and thought about a better solution. And then we said, okay, if we need styles on the top and we need scripts on the bottom, why not add the ESI includes here? And we did it and said, okay, please, here come the header styles. This is my content I want to see in the middle, and on the bottom I need my script tag. And Varnish goes over the page and says, okay, I will resolve it. Here you've got styles, here you've got content, here you've got scripts. So that's actually looking pretty good. Well, they are not combined, so the browser has to do 2 requests to load the CSS and the JavaScript, but hey, at least better than the first try. Problem here is we're using caching. So let's say you say on your backend, you say, okay, here we have a time to live of let's say 1 hour. And for the content, it's also cacheable, also 1 hour please, and on the script, okay, also 1 hour. The problem is that the cache is not synchronized, which means in the end, it could be that this part is out of the cache and Varnish will already fetch a newer version. And those parts are still the old versions, so you get inconsistencies. So your versions might work together, but it's not guaranteed. And in the end, if you do a lot of changes, introducing new objects on the page, it's very likely that the style is missing. Yeah, well, so what to do? We had a lot of problems. The page speed was bad. When we tried to optimize it, it was rather more complex and had TTL errors. So we thought, okay, we can't show this to anybody because people will go mad about having 3 includes, and we didn't even solve half of the problems to get proper page speed. So these are the additional issues. Combining assets could be done by having a dummy file with 2 ESI includes, and Varnish will combine them. Okay, very complex. All the assets that are then combined cannot be strong cached, so he has to do the combination on every request. Also bad. And then we got the killer argument, because we're running on AWS. We try to have EUB as backends, and on AWS, an EUB consists of multiple IP addresses because of the availability zones. And Varnish said, well, I can start because there's more than 1 IP address. So, okay, we had a bad week. And so, yeah, and we thought about, okay, how do we get out of this mess? And then somebody said, well, what is the best tool to make a page faster? And well, it's something that yeah, can work with all these issues that we have. So what we learned is we need the reference of the styles and the scripts in the fragments or in the pieces of HTML to be consistent. We need something that can do post-processing because you cannot combine things you didn't see yet. So this means the page has been fully combined and afterwards you need to optimize it. We also want to have combined assets. It's a good pattern. Inlining would also not be a bad choice. It helps you. And yeah, so as we're doing immutable server deployments, it would be nice if we didn't kill the cache on the release. That would also be good for the backend systems. Yeah, so we were thinking hard. And if this thing works, then we came up with Jigsaw. Why Jigsaw? Because we were putting together some pieces. And I can remember the week where we had a pretty bad mood and then we were thinking about how to solve this. And somebody said, okay, the best tool to get a page speedy is to use page speed. So, ta-da, this is actually how the solution looks. So Jigsaw is basically this box here. It consists of multiple components. The core component is an Nginx web server. It's just a plain web server, no modifications whatsoever. And what are we using from Nginx? We're using the SSI module. We're using Nginx page speed as the thing that will boost our page. And of course we want to do proxying and we also want to cache the responses of the backend system. So to explain a bit, SSI is basically the same as ESI, except that it only knows about local paths, so you can't reference a remote location. You can only reference local locations, and therefore we need to configure the backend services in Nginx and say, okay, if there is a path, let's say /home, it will go to the homepage service, and if there is a path /header, it will go to the header service. So those need to be known in here. And then Nginx can do the same as ESI, but with SSI. And to make the page fast, we use the page speed module with a few filters. On the right side, we see some caching here. We have a cache for the page speed module, and we have a cache for the proxy. I will come to that later. Alright, so how does it work? First thing is Nginx gets a request, pretty easy. Then Nginx determines the backend service and says, okay, this path is the homepage service. So I will go to the proxy module and say, okay, please fetch me the homepage. And what he gets back is basically a page with the SSI includes. You get a page and it's written down, okay, here is the header, here's the footer, like in the easy example, but with SSI tags. And okay, third step is then the SSI module parses the page and says, okay, what do I have to resolve? It will resolve like Johannes did it with ESI. It will resolve all the paths, the include tags. And it's also using the proxy module, and it goes to the header service because /header is known as the header service. And what it gets back is a piece of HTML code. And this also contains the style and script references. Okay, so far so good. Then let's assume we have resolved all the includes. PageSpeed walks over the page and says, well, okay, what CSS and JavaScript do I find in here? What do I have to do? And what's nice about PageSpeed is that it prefetches the assets. It means PageSpeed parses the page, and because it combines assets, it will generate new paths. And to be able to do this, it has to know upfront which paths it will generate. And it will prefetch all the CSS and JavaScript that is in the page, that is referenced in the page, from the header service, for example, and will also combine it and replace the reference with the new combined URL. Yeah, and the final step is then send the proper page to the browser, and the browser hopefully is happy.
All right. Before we now show an example how this actually looks in the code of the page, I want to explain that we conceptually distinguish between what we call a page and what we call a fragment. So a fragment, a page is publicly accessible by the user, whereas a fragment is just a part of the page. That means a page gets called directly from the client, whereas a fragment only gets called from Nginx's SSI module when resolving an SSI Include. That also means that actually the fragment doesn't know the original request. A page obviously includes fragments, but fragments could actually include fragments as well. So you could have arbitrary nesting here, although we probably wouldn't advise to go too far with that. A page could be cacheable. Obviously that's nice to have, but yeah, there are various reasons sometimes why it cannot be cacheable, too much dynamic content or so. On the other hand, a fragment should really be cacheable, so ideally a fragment is a more or less static small piece of content. And then finally, a page is actually owned by a team, and that team is responsible for the performance and for the stability of the page. So therefore, when the page includes any fragments, then the page or the team that is responsible for the page defines some contracts for that fragment, and then the job of the fragment is basically to adhere to those, or to that contract. Yeah, a simple contract could, for instance, just cover the space that the fragment is taking in order to not break the whole layout of the page. So now let's look at a simple example here. Again, similar page. So yeah, this is a page. You see that because there are those HTML tags which would not be there with a fragment. Apart from that, you have a normal structure with a head and a body, and then you see here that the page already comes with its own styles. Those are already minified and combined, but those are only the styles that are actually used by the content that this page comes with. Also, the page already comes with its own JavaScript. Again, this is the JavaScript for the page, not for any included fragments. And then here you see the actual syntax of SSI includes. So this is basically just HTML comment, which then starts with hash include virtual, and then refers to some upstream service. So here we include the fragment from the header service for the German header. And now, as we've seen it before with ESI, SSI, or the SSI module, actually simply replaces this include with the content that is delivered by that upstream service. So this is the fragment here now, and you see this fragment has a similar structure actually as the page. So it also comes with a head part. There are some styles. Those are the styles of the fragment, and again those styles are already minified. So they are coming in minified version already from the upstream service for the fragment. Then this also comes with some content, and also there is some specific JavaScript for that fragment. Now, again, as of now, this page has a pretty bad performance because we have styles and JavaScript scattered all around the page. And now, actually, Nginx page speed comes into play, first with a filter for combining heads, or combining head elements. And you see here now, actually what has been in the head of the fragment, now got into the head of the page. So here you have the styles for the fragment. So the head section here is gone. Here's the content of the fragment, and but we still have the script part of the fragment. So still not ideal. And then there is the combined CSS and JavaScript filter of Nginx page speed, which then combines all those styles here in this head section, so that there only needs to be one request for that, to load that. And down here it also combines all the different JavaScript and also defers its loading and does so asynchronously. So now also the JavaScript here is gone, and basically the only thing that is left now from the fragment is the actual content that came from that header. Yeah, and that's basically it. So now all the post-processing is done. And what we actually then get from this are pretty great page speed scores. So we just took some of our composed pages, yeah, for this particular page we got a score of 97 for the desktop score, which is actually pretty great, and still 96 for the mobile page. Yeah. And yeah, now Yo is going to tell you something, yeah, about the caching.
Okay, yeah, as we said, caching is pretty important, especially for fragments. If you assume you have a page of multiple includes, it's adding a lot of latency if the requests are slow, so we strive for caching wherever possible. Yeah, as I said, we have those caches on the right. Just to recap, basically we have two layers of caching. One is the upstream cache, which caches the responses of the services. And because page speed is also doing some calculations with the assets, it's combining those and generates CPU load. We try to avoid burning the CPU by also introducing the cache here, and yeah, that page speed stores already done work in the cache. What we are using here is ElastiCache. It's an AWS service, and it's basically providing a memcached instance in a managed service. And this helps us a lot because we can now offload the cache of the machine. So for our immutable server deployments, this is great because the cache is never cold, and AWS is caring about yeah, keeping it alive and doing some magic in the background, and we're just using it. And also it's pretty fast. So yeah, as I said, two caches. The one is for the generated assets. It's on AWS, and we can have the stateless web server machines, and we don't need to care about cache synchronization or any complex handling of the cache content during deployment. For the proxy cache, it's just yeah, storing the responses of the backend services. And we're not doing any TTL override or magic there. Every service tells us which or how long we can cache its content, because we believe that the teams and the services know the best for their service regarding caching time, and there are also some business requirements behind that where you might not know anything about on the UI composition layer, so this should really be a task of the teams to define their caching times. Yeah, we just use the cache headers and do whatever is needed there. And there is also the very header, which I will show you later on with an example, which is also pretty interesting. protocol extension of the HTTP protocol. And yeah, it's also respecting this. And also for this, we had to introduce the SR cache module. It's a bit an extended module for Nginx. Nginx by default cannot do it, but with this module, you can also write into the memcached instance. Normally, I guess you can only read, but this module allows writing. So in both cases, AWS is caring about persistence, and our machines can die and can be recreated without any problem. So let's look at a few examples. First example is assets. So we have an upstream service, and we get CSS and JavaScript, and we have a proper cache control header that says, okay, please cache me 1 hour or 2 hours, whatever the service wants to tell us. And what happens is, as the page speed module is fetching the artifacts, the assets, it's also using the SR cache module, and therefore it's, in this case, it's cached in both caches because it's written into this cache for the proxy. And afterwards, Elastic Cache PageSpeed is also combining the asset and storing the combined assets in here. So this gives us a bit of resilience, because if the backend would be down, then we still could fetch the assets from the cache. So it's better to serve stale content than no content. So yeah. Then a case that should actually never happen is uncacheable assets. So actually, I can think of a reason why you should do this. So yeah, just to tell you what happens, nothing. It will most likely burn your CPU because PageSpeed has to recalculate everything. So you should really try to avoid this. What about documents? So assets are easy. What about documents? We have pages or fragments that we fetch from the upstream service. There also we could have the case with a page, true dynamic page that is not cacheable. Exactly nothing will happen. The request will go down to the upstream service at every time. And no cache is written, and PageSpeed is not included at all, because this is just the SSI resolution, so PageSpeed is one step further. So in that case, no cache is used. In the positive case, where you have maybe a fragment that can be cached, it will of course be put into this cache and be served out of this. And here we have the advantage now that even with a lot of SSI includes, it will still be fast because it's fetched from the cache. And we are using this, for example, to also save requests to DynamoDBs, because we can calculate the response once, and we are saving pretty good money here, because we don't need the DynamoDB access every time. Then, as I said before, the very header, it's a bit tricky. I hopefully chose an easy example. So assume you have an upstream service that serves different content based on some condition. In this example, we have a cookie, it's named culture, and it can contain the values, for example, that the user chose, I want to see this page in German or in French, and it will be stored in this cookie. So normally if you have upstream services, you don't maintain multiple domains, because it's just overhead. So what we have down here is an upstream service with a .com domain, and actually if the cache or the proxy is connecting to this upstream service, the upstream service wouldn't even know which country the user chose. Why is that so? Because in this case we assume that's a fragment, and SSI includes are so-called sub-requests in Nginx. So that means that a request that is triggered by SSI doesn't know the original request. So in the end, this service doesn't know the cookies and anything else. So what we have is, we have some cookies that we know of. One is the culture cookie. And what we say is, okay, if you go to the backend, please set a header in which you transport the cookie value to the backend. So this header sent to the backend contains German or French or whatever. And then the upstream service says, okay, I know that I get this header and I can distinguish which content to deliver based on the language. So what I do is I vary by culture cookie. And if you tell Nginx that you vary by some header, for example, then he will add this, this information to the cache key, which means if you have two requests with two different values, you get two entries in the cache with two different cache keys. And the next request that comes from the browser will know this and will basically get this the correct version because the header is set in the correct way. And you can use this for different situations. For example, we have some unsolved problems yet that we need to think about, and one might also be how you get A/B testing done. And in A/B testing, cookies or parameters in the URL are often used, and you need to get those back to the backend. And if you have a cookie with the very header, you can still serve different content and still be cacheable, and that's a good thing. All right. So speaking of A/B testing, we got a lot of feedback from the teams. Okay, how can we test this? It seems like page speed is modifying the page, and how can I be sure that this works? So what we thought about is, okay, how can we test this locally? So assume you have your page. It consists of the home page itself and a header and footer fragment again. And what I want to do now is I want to change the header, but I fear that I might introduce some change that will break something else on the page because my styles are broken or anything else. So yeah, Nginx is running in production. How do I get my stuff in there and test it before going live? And what we developed there was basically Jigsaw in a box. So this environment that we have on production, we also have a Docker container for that. And the only difference here is that in this container, caching is disabled because you don't need it for local testing. And what we do is basically, let's say we want to change the header service and test some new style or anything. Then we basically say, okay, I have my local header service running on my machine. And whenever you get a request for this, don't go to production as an upstream service. Please use my local one. But the rest, homepage and footer, should be in production because there is the truth. So we try to integrate against production whenever possible because there we can be sure that this is the current live version of other services. So we are also using the production services here when we do local development. You have to be a bit careful what you do, yes, but in the end, you're testing against the working copy. So yeah, that's how we do local testing. And another thing that we found out was when teams started to use this service, we got a lot of questions because their page speed was bad. And when we looked into the problems, we found out that there are some situations where the module page speed might have a problem doing what it should do. For example, if you write defer async in your scripts, in the fragments, for example, page speed will not touch it and will not combine it with other scripts because it doesn't know what's the correct order. So what you do is basically you don't do this in your fragment and let page speed do it afterwards, so it can defer JavaScript automatically. So that's why you shouldn't do it here. Another thing is there are so-called page barriers. If you have an inline script, then page speed will also not combine the scripts above and below the inline script, but only those, if you have two scripts above the inline script, it will combine those, but not across the border. So you should avoid this. Then there's CSS outside of head. Yeah, okay. Style sheet references with different attributes. So one example is the media tag. If you have a style for media print and a style for media screen, it will not combine those two. Yeah, and our convention is that assets are located in /assets. So that's also tested. And this is just basically a script that you can run against your code or any running service, and it will just parse the output, the HTML, and test if you have something in there that is bad for the page speed optimization. So this helped us because we could just say, okay, please let the script run and see what it tells you, and then you have solved 80% of the issues. And you can also run it in a deployment pipeline, so you can avoid pushing something to live that might break your page speed. All right. As I said, or as Arif said, we have this project now for over a year and still didn't solve everything yet. So there are some open topics. One thing is how we can handle authentication with fragments. How you get the authentication headers to the fragment services and things like that. And yeah, A/B testing is also an unsolved problem. And those two might have the same solution. They could be solved with the very header, but we didn't look very deep into it. Then we were thinking about if two components on the page need to talk to each other and they are served by different fragments, how can they interact with each other? And currently we are using window event or event-based interaction, but we don't have a final solution there. And another thing is a bootstrap fragment, because we found out, okay, we have a font on our web page that's pretty large. We shouldn't load this on in every fragment. So we thought about, okay, there might be some things that are common on every page, and we should include this on every page. So why not create some global fragment that we can include in every page? And yeah, so native mobile apps, as Arif already said, their UI composition is a bit more difficult. All right.
Okay. Thanks. So let's conclude this. So, what are actually the features of this UI composition solution that we developed, and which we call Jigsaw? So now, with this solution, teams are actually in full control of their services UI, and they do not need to rely on other teams when changing this. So they can do completely independent feature releases, of course only as long as they stay within the boundaries of their contracts. Of course, if they break the contract, then yeah, they have to go to the other team and talk to them. It's still needed. Also with this solution, fragments actually have a simple structure with a head and kind of a body part and the script parts below that, and it's in one file. So yeah, it's relatively easy and straightforward to provide fragments. As we've also seen, page performance is not compromised in any way. It's actually really good. Also, we saw that Jigsaw serves as an effective caching layer, so that we can also yeah, have good caching here using Jigsaw. And as we've just seen, fragments can be tested both in isolation and in integration with other fragments or pages. So overall, we're actually pretty happy with this solution. It really solved the problems that we had. So there are a few learnings that we had and practices that we keep doing. So the most important thing for us here is that we try to keep this composition layer as simple as possible. So we therefore, for instance, made sure that we only turn those filters in page speed on that we really need for this thing to work. we have this UI composition layer basically very much at the top before every page. And yeah, you can easily come to the idea, well, we have this thing here, so let's put all kinds of optimization in there because it's just there, and then every page and every fragment will benefit from this. However, then the composition layer would become more and more complex, and we would have kind of a monolith there again. So we really want to keep this simple so that not many things can break, and that it's also easy to be understood, so that it doesn't feel too much like magic. Furthermore, we stick to HTTP protocol use cases, such as the vary header, so that actually services can control Jigsaw's caching behavior themselves. So this is also for transparency. Well, just for that last, that last slide here. So we isolate fragments from each other by using CSS and JavaScript packages. So yeah, they use their own packages so that we have no name clashes and so on. And so far, actually, our experience is that this is enough isolation. Although actually there is no real isolation, but so far we actually didn't have any big problems with just this case, this kind of isolation here. Yeah, and finally we try hard to have good documentation so that it's really clear what this layer is doing, and yeah, that everybody knows how to use it and yeah, understands it. All right, thanks a lot. We're now really happy to answer any questions that may have come up. Should I pass around the mic?
Who owns the Jigsaw service? Is there a dedicated team or is it shared?
So what we are doing is we are assigning services to teams, so teams are responsible for services. So currently there is one team that is operating this service, but it doesn't have to be like this. So you could, in theory, have multiple instances of this composition layer. You could even have one per service if you want to do this. And then every team could have its own composition layer and operate it on its own. So currently it's shared in our case because we have one and it's working, and we didn't see the need currently to go for more, but you could.
So, does that answer your question? Any more questions?
Yeah. Up here.
Okay, well, this is closer to
I can hear. You want me to come?
Sorry, quick one. How do you deal with Bootstrap or with jQuery or this kind of resources? Because they are shared on the UI, I guess.
Well, so I think Johannes already mentioned it. We're currently in the process of thinking how we deal with bigger shared resources. So the idea here is to have a Bootstrap fragment, which can then be included by any page or a fragment. So that would be transparent again. But in fact, we're still in the discussions how we deal with this. Yeah, so, but that's currently our plan to do this.
And we also try to avoid libraries like these. So we are currently, we have our own UI library, but we don't use any big JavaScript library for now.
Does that answer your question?
Yes.
I have a question regarding caching. From the proposition layer, do you actually evaluate the cache headers of the fragments? Or, in other words, one thing for the distributed teams to have raw cache headers. Because if they just said something like max age is 1 second or something, it makes it much more easier for the team itself for their fragments.
So currently we just trust our teams, that's the first thing. So you shouldn't be stupid in that situation. And the other thing is that if you set very low cache headers, you will shoot yourself in the foot. So it's better for your service to have a proper cache header and not just 1 second, because I assume if you have 1 second, then you want to say my fragment is not really cacheable, but I want to save some requests. And that's not a good option. So you should really look at the business needs for your fragment. If it's something that needs to be updated immediately, then it's definitely not cacheable. Then you have to think about different solutions. And if not, then you could maybe set a minute, which will save you a lot of requests, but still gives you the option to, when releasing, see your changes pretty fast. So 1 minute is also what we are using in many cases.
So I think we see this Jigsaw more as kind of a tool for the teams. So in fact, a team can also turn off caching completely. Yeah, but we rather want to make sure that they understand how it's working and how they can basically get the best out of it, right?
Thank you for the presentation. I actually enjoyed it a lot. One thing that I noticed is that if you combine every JavaScript and CSS, that means that you're relying on not having very frequent releases done by your teams, or you're invalidating your cache basically quite frequently. So have you noticed this, or do you see that this does not clash with your like normal release cycles? Because if there is a team that releases every hour, then your JavaScript, if it's also is big, if it's invalidated every hour basically.
Yeah, that's really one of the trade-offs of the solution. So, yeah, one thing is, as we said, we don't use those huge libraries, so the JavaScript code that we have on the page is rather small. So that's one thing that helps you. Another thing is that you could configure page speed, or with an attribute you could tell page speed to not combine certain assets, which means, for example, you have a rather big JavaScript where you know this will not change, or it's better to store this on the browser than to recombine it every time. Then you could make you could exclude it from the combination, and then it will be strong cached on the browser, but it will not change with every release. It's only changing then when this fragment is updated, because then you get a new hash.
Okay. One last question: why do you use include in the comments? Is it something that you introduce, or introduced by one of the components that you're using? Because I found it a bit strange that you use comments actually for including.
Yeah, that's the SSI specification. So the tag, the SSI Include tag, is just written like that. It's not an HTML comment, or it is a comment because the browser doesn't see it, but for an SSI parser, this is a valid SSI tag that will be handled.
Okay, thanks. So you have no nightmares that the product guys say we want to have the native UI, and then you end up with two solutions, which means the gateway API and the sophisticated caching solution?
Yeah. As I said, we haven't thought about the native apps too much with respect to that UI composition. Yeah, I think finding a similar solution for native apps is probably quite challenging. Yeah, we haven't looked into it.
But you have no requirements, so that you have also on the mobile side, you just have a web client, and that means you're okay with that at the moment.
So the question was whether we have any requirements there.
Are you talking, so our pages are fully responsive, is that what you mean?
No, what I mean is that sometimes you have product guys which say, oh, we want to have all these nice features which are on the, let's say, iPhone thing. And because we are anyway, most of the customers who are buying some cars, they have iPhones, I don't know. So let's focus on that, and then you have a requirement that you should use a native one, which would mean then that all this sophistication you put into the solution is only half of the value.
Alright. So yeah, I think the native apps are already really important for AutoScout, but so is the mobile web.
Okay.
So I would say this is a solution for the web, and particularly the mobile web, where I think we get most traffic by now. Yeah, but I mean, even if we have to focus on native apps, then this work is still important for the web, right?
But that means you're building two, right? Because we're saying that native apps are important. That means you're building a gateway API also because you have to satisfy those guys with your microservice infrastructure.
Could be, as I said, yeah, we didn't really look into this yet.
Okay.
Hi, thanks for your talk. Maybe I'm too new to microservices, but what I wonder is, so far you gave the examples header, page, and footer, and I assume header and footer will not change so frequently. So when you bring up topics like A/B testing, and you have different fragments on a page that is owned by different people, how can you prevent multivariate testing? Like, because A/B testing, you only want to change one thing. So why is it that you want to have different people in charge of all those pieces? Can you maybe explain that a bit better to me?
So, of course, so the main idea, as I outlined in the beginning, is really the team autonomy, so that people can act independently. I think you can certainly go too far with this approach, and I don't know, have 20 different fragments from 10 different teams on one page. I think we want to avoid this, although we are actually experimenting also how far we can go with this and how far it is practical. Yeah, in terms of testing, I mean, as we saw with this Docker-based testing solution, you can basically test your fragment against what's currently live, so you're just changing one thing. Yeah, I don't know.
No, I mean for A/B testing, if you do UI changes, then you want to have a different conversion rate. Like, you don't want to change 3 pieces at a time, because then you cannot really see what happens.
Assign, I mean, the pages kind of manage the components, right? So you could assign time slots, for example, to different components. So only one component is tested at a time, for example.
Yeah, so I mean, in the end, of course, the teams have to talk to each other. I think this is not avoidable by our solution, so we cannot solve this by technology yet. So yeah, I mean, as I said, the page owner, the team that owns the page, is responsible for the page. So yeah, so they have to make sure that the page keeps stable, or if they want to do an A/B test, then maybe they have to talk to the people that provide the fragments to avoid such things. And so, does that answer your question? Kind of. I mean, it's a good question. It's a tricky thing, I think.
Thanks. Have you had a case where
your page was broken and none of the teams to take the blame for it. I mean, maybe I want to ask, tell us something more about your release process. Do you have a constraint where one team can release and the other one cannot, or how does this work?
Good question. So, what you mentioned is if one team cannot release, the advantage of this solution is that another team doesn't have to wait. So that's the advantage of the solution. On the other hand, yes, we are aware that the risk of breaking the page is a bit higher because it's a dynamic process that happens after you run all your tests. So you need to implement proper tests, and what you can do, for example, is you could also use the Docker container in the build pipeline and test there with, I don't know, Casper.js and things like that. So you can do it automatically. And in the end, what you also need to have is proper monitoring. So if you break your page, you should at least find out very quickly and also be able to re-release maybe the old version or a fix. So the deployment process, your monitoring, and also talking and proper testing, those are all things that you should have in place to be really confident about what you deliver to live. And that's no difference in this solution. If you have a service in the API gateway pattern, it could also be you deliver a broken version and all the other services that depend on it have a problem there. So that's kind of comparable, and you need to find out what's the proper amount of upfront testing, what's the proper amount of monitoring, and how to fix fast.
I mean, answering the question whether we had such a case, I think we had minor cases of this, like the page speed went down, for instance, because something has been included with some inline script or something like that. But I think we had not huge catastrophes so far with this approach. Yeah, I mean, I think it's what we really want to achieve is this team autonomy, so that teams can really work on their products as independently as possible. And I think there are trade-offs that you take when you want to go into that direction. And of course, this brings some risks as well. So then you have to come up with testing and monitoring and balance this out. How much risk you want to have to break things and how much you want to allow for teams to go independently.
I don't know if you have considered, but do you think in the future that maturing standards like web components will bring you to reconsider UI compositions and a bigger role in the browser? Or you think that server-side is more control and a better way to go? I mean, I don't know where they are, the web components in the tech rather than in the future, maybe a higher, bigger role of the browser as an integration layer instead of the Nginx server side.
Good question.
So I think in the future there will be some things that will make those things easier. Like web components. Also HTTP would be, HTTP2 would be an example where it helps you get the content faster to the browser. For now, we needed a solution, and web components is somewhere in the future, but we concentrated on the solution for now. And also with HTTP2 on AWS, it's still not supported, so there was no need for us to look deeper into this. But when the time is there for these technologies, we will certainly reconsider it. This is not a solution for the next 10 years or so, definitely not.
Yeah, I'd say we built this solution for now. I think when did we start to build? Maybe half a year ago, something like that. And right now we're actually quite happy with it. It solves the problem that we had. Yeah, but could change in the future, of course. Another question around here? No. The question moved back
I
there.
don't need a microphone. Just a question towards dynamic content. And are you really prepared to give up all possibility of D3 libraries, drag and drops, so that you don't have to write yourself?
Well, I'm not sure whether we really completely give up those opportunities by this solution. So if this solution completely renders this impossible, we could still have fragments, different fragments from the same service on the same page where this could work. Yeah, I'm not sure about that. So far, yeah, let's say on the AutoScout page so far we didn't see this as a huge problem. Yeah, I guess that's a short answer.
Can you share a number of teams you're managing?
I think that's like 8 teams right now, 8, 9 teams. I don't know how many services. I guess 15. You know. So yeah, in that ballpark. Okay.
Hi, thanks for the interesting talk. I haven't been to the previous meetups. I don't know whether it's production, whether you still have the legacy. What's the state of this implementation?
Okay, so that's yeah, basically a question that refers to this project Tatsu that I outlined in the beginning. Well, we're right in the middle, I would say. So yeah, it's yeah. There are a few services now live with a new stack and that are already using this UI composition, such as the .com homepage and a few other services. But actually, most of those. So we're rebuilding lots of services already, but I would say many of them are not live yet. So yeah, we're right in the middle of rebuilding everything and then gradually bringing the new services live. So actually many services already use this Jigsaw UI composition solution, but there are not so many services that are using that are already live, but some are. So I don't know if that answers your question.
Maybe a follow-up. Is there any tension between the old teams and the new teams?
Of course. But I think the direction is clear. I mean, there is no going back. So there might be some tension, but yeah, the new tech stack is the future for us, and so is also this UI composition. All right. Any more questions? Okay. Then thanks a lot.